Welcome to Colorado Engineers 2011. I'm Bill Hoffman, President of the American Council of Engineering Companies of Colorado, and I'll be your host for this program that takes a look at projects that were designed and completed by Colorado engineers in 2010. The projects you're about to see were recognized by the Engineering Council for their engineering innovations and sustainable solutions using the technical expertise and practices that engineers employ every day for the ongoing health, welfare, and safety of communities. Joining me is Jim Bradburn, Chairman of the Board of the United States Green Building Council Colorado Chapter, and throughout the program, Deb Kleinman, Executive Director of the United States Green Building Council Colorado Chapter, will examine the sustainable aspects of the projects as they relate to our citizens from an environmental, social, and economic perspective.
The most common and accepted definition of sustainability is providing for the needs of the present without compromising the ability of future generations to meet their needs. Now, this definition can mean different things to different people, which is good because sustainability comes in many forms. It goes far beyond just saving energy or reducing pollution. It encompasses the whole scope of our built environment, from water infrastructure to transportation management to resource reduction. This is evident in the scope of sustainable solutions demonstrated in these projects. Although mechanical engineers have been thrust into the spotlight with the emphasis on energy conservation, all engineering disciplines play vital roles for a sustainable built environment. As the demands on our energy and material resources grow, engineers will be asked to provide innovative solutions, not so much for us, but for our future generations.
Colorado engineers are at the forefront of creating the infrastructure that maintains and enhances our quality of life now and into the future. They employ skill and knowledge and create new technologies and processes that will affect how projects are designed well into the future. Our program features 5 projects in Colorado: Casey Middle School in Boulder, a water purification plant in the city of Centennial, the Prairie Waters project at the Peter Binney facility in Aurora, the 6th Avenue Waste Tire Noise Wall in Lakewood, and the National Renewable Energy Laboratory Row 4 turbines in Golden. We'll learn how Colorado engineers designed a cellulosic biofuels plant in Soperton, Georgia, and performed a first ever piano key weir model study for the Dartmouth Dam in Dartmouth, Victoria, Australia.
Colorado's engineers are leading the way to creating sustainable solutions that not only impact our state, but also enhance the infrastructure of communities nationwide and globally, creating solutions that impact quality of life. We begin by taking a look at the National Renewable Energy Laboratory in Golden, Colorado, where we are today. NREL's newest building, the Research Support Facility, is arguably one of the most sustainable buildings in the country. It's pursuing LEED Platinum certification and is expected to use about half the energy of a comparable building built to current code. This feat was achieved through an integrated design process which, among many other things, maximize the daylighting while minimizing the heating and cooling needs. Additionally, NREL has implemented a comprehensive program to reduce the energy need for the office equipment. And finally, photovoltaic panels will be installed on the roof to offset the remaining energy to create a net zero building, a building which produces at least as much energy as it consumes.
At NREL's National Wind Technology Center, scientists work to improve wind turbine technology to meet soaring worldwide energy demands. Before this project, the largest turbines tested at the center were capable of generating 600 kilowatts of power. To accommodate much larger turbines, capable of producing 5 megawatts of power each, a new site electrical infrastructure was required. The RMH Group designed a robust new electrical infrastructure to handle these power requirements. The design is capable of accommodating total output of up to 10 megawatts of power while simultaneously improving control and capacity. The built-in flexibility of the RMH design will give researchers the ability to answer emerging questions and to test even larger, more complicated turbines as they become available. NREL will now be able to achieve greater economic independence and have greater resources to invest in future research activities.
Design for utility-scale wind turbines next to ongoing research projects required system flexibility and electrical isolation. Our success depended on team coordination and system balance. The importance is, this project enables the Wind Technology Center by the DOE to further investigate the dynamics of wind. And in doing that, they can do this with a large-scale, utility-grade wind turbine, which will put more power on the grid. We have to handle that. They've been doing piecemeal wind projects so far with smaller turbines, testing blades and things like that, but this will enable them to really realistically put power on the grid and test what the dynamics are of that wind turbine.
The National Renewable Energy Lab is one of Colorado's greatest assets. Their mission is focused on advancing our nation's energy goals, including the development of a new energy economy. They translate research rapidly into market-viable alternative energy solutions, including wind energy. These particular turbines are tied directly into Xcel Energy's utility grid and will to about 500 megawatt hours per month, which powers about 830 homes during the windy season.
Casey Middle School of Boulder, Colorado was an 85-year-old outdated and inefficient building that no longer met the Boulder Valley School District's needs. The Boulder community sought to replace the school on the same site, but not without setting high sustainability and efficiency goals for the new facility. EMC engineers were brought on to the project to design the facility's mechanical and plumbing systems. EMC's high-performance design met the objectives for efficiency and sustainability. Although the new school has an additional 20,000 square feet and capacity for 200 more students, Boulder Valley School District can expect lower utility bills and fewer maintenance calls with EMC's design. The building will achieve LEED Gold and possibly LEED Platinum certification, which would make it the only LEED Platinum school in Colorado.
Casey Middle School will use about 42% less energy than a similar sized school due to the advanced design while providing a more comfortable learning environment. I was probably most proud with the way that the whole system concept came together, the way that the different components of the system integrated to provide a significant energy savings. The school, of course, will use less energy and therefore their bills will be lower. But the school is also going to use this as a learning instrument for the students who are going to be taught about their building and how it works. It's really great to have your name associated with a project such as this. The community, the staff, and everyone involved really got behind the project, and it's great to have my name associated with that.
This project is near and dear to my heart. Green schools are a major focus for the U.S. Green Building Council Colorado chapter, and our vision for schools is green schools for everyone within a generation. LEED stands for Leadership in Energy and Environmental Design, a widely recognized third-party rating system for green buildings. Certifications are awarded at 4 levels: certified, silver, gold, and platinum. The greener the building, the higher the certification. Achieving LEED Gold is impressive. Achieving LEED Platinum for a school is remarkable and raises the bar for schools in Colorado and across the country.
Faced with developing a sustainable water supply for their growing population, the Arapahoe County Water and Wastewater Authority and Cottonwood Water and Sanitation District combined to develop the Joint Water Purification Plant. The facility is designed to serve as an indirect potable reuse system, allowing wastewater effluent to be returned upstream of raw water supply wells and reused for potable supply. This plant uses reverse osmosis and advanced oxidation technology to produce one of the safest water supplies in the state. It is the only one in Colorado, and one of the few in the nation, that uses this combination of treatment processes. Arbor Associates served as the project manager and lead process engineer for the plant. They worked with both agencies to develop a successful project that serves as an important component for a long-term sustainable water supply.
The Joint Water Purification Project demonstrates the feasibility of communities implementing indirect potable reuse as a long-term sustainable and cost-effective water supply strategy. The Joint Water Purification Project made a big step towards communities understanding the feasibility and acceptability of reuse as a potable water supply source. It's a new application of water supply strategies. The benefit of the Joint Water Purification Project is getting more use out of every gallon of water that we supply to the consumer and being able to reuse that gallon of water multiple times, thereby stretching the water supply. It goes a long ways to having to reduce the amount of infrastructure and cost for obtaining additional water supply sources for communities.
Here in the West, whiskey is for drinking and water is for fighting. Water scarcity and water contamination are enormous environmental challenges in the Southwest. Effective treatment of contaminated water, combined with maximizing reliance on wastewater, help to address this critical issue. The design of the facility incorporated several sustainable elements, including energy-efficient equipment, natural daylighting, and energy recovery equipment. These strategies combined will save the district tens of thousands of dollars every year.